As a computer performance analyst, you will be required to look at many different performance reports and many different capacity reports. In fact, you might even be expected to create your own reports. In order to create a report, you have to ask questions of the data you have available to you. So understanding data is a key component to being a computer performance analyst. During this session, I am going to talk about what I consider the two key primary categories of data, and I will give examples of each. Now, this particular session is geared towards computer performance analysts, but if you're someone who's responsible for reading reports or creating reports of any kind, then you'll learn something hopefully in this particular session as well. So stay with me. Hi, my name is Peter Enrico from Enterprise Performance Strategies. My team and I are here to help you get great workload performance while optimizing the usage of your system resources in an enterprise computing environment. Our education and our software are geared towards helping you get better performance results and faster. Now, if you're new here, click the subscribe button, and any of the references I give in this video will be linked in the references below. So let's get into it. As a computer performance analyst, you will be asked to look at quite a lot of data. In fact, you will be asked to look at many different measurements and many different types of measurements. And sometimes it's hard to figure out which measurements to look at and why you should be looking at those measurements in order to help further your analysis. Today what we're going to talk about is data. In particular, what I want to talk about are what I consider the two key categories of data, and then some subcategories and examples of what those two key categories are. The point of the video is to help organize in your head what data to choose from and how to use that data when you're asked to do an analysis or to create a report. Now, if you stick around to the end of this video, what we're going to do is I'm going to give you some fundamental steps you need in order to create a report that you're going to be using this data for. So stick around to the end, and I'm looking forward to spending time with you. Now, as I said, all reports are designed to answer a set of questions. And the way we answer those questions is by taking data and building it into the report. Now, I think of data as being divided up into two primary categories. The first category is what I think of as metric data. Now, metric data is going to be those measurements that we're going to look at the relative value of to give us some insights for our study or analysis. Or another way we can think about it is we think of metric data as being those measurements we're going to use to gain an understanding in order to answer the question that the report is designed to answer. Now, when we think of metric data, there's lots and lots of different metrics that we're going to look at in the computing environment. But when we look at it in terms of broad categories, there's certain broad categories of types of data. So for example, one type of data is what we're going to think of as cumulative data and interval data. What cumulative data is in your operating systems and in your hardware, you're going to have certain measurements that are forever accumulating. So if you were to look at them over time, you see them accumulating, and then you can see the rate of accumulation and what the pattern of accumulation is. And so cumulative data. But many times what many performance monitors will do is delta those to come up with what we call interval data. In particular, what a measurement data gatherer will do, a performance monitor will do, is it'll take a cumulative value and collect it at the beginning of a measurement interval. And then let's say the measurement interval is 10 minutes, so that it'll let 10 minutes go by, and at the end of the 10 minutes it'll collect that cumulative value again, and then at the end of the 10 minutes we have a before value, we have an after value. If we delta those two values, we're going to come up with what we call an interval value, which is how much was accumulated over that 10-minute period of time. That is an interval value. I guess another measurement we're always going to be interested in is going to be snapshot data, or the specific value of interest. So we snapshot and we get a value of something. Many times the reason we do snapshot data is because we don't expect the data to change very often, so why go through the overhead of constantly looking at it? Or many times what happens is a snapshot value is collected because the measurement of interest is so expensive to collect that what the measurement monitors will do is it'll collect it very seldom. So maybe at the end of every 10 minutes it'll collect the snapshot value, and that's good enough to kind of get a feeling for what the value is over a period of time without having to go through the expense of constantly collecting it on a more granular basis. Another measurement we're going to be interested in is what we call sampled values. Now, sample values are interesting because that's a case where we want to kind of get a feeling for what a measurement is, sort of a min-max average or maybe a distribution. So typically what a monitor will do is it'll have a measurement that it wants to sample, and it'll set the sample rate. Let's say the sample rate is every quarter second. So what it'll do is it'll wake up every quarter second and collect a sample of that data to calculate the min, max, and average. So for example, let's say we want to find out the min, max, average of a particular queue in the operating system. The way we do that is the gatherer will sample it every quarter second over a 10-minute period of time. And every time it samples it, it's going to look at a sample and it's going to say, is this the smallest measurement I've ever seen during this sample? If so, it's going to remember it, and that'll eventually become our minimum. Then as it's sampling, it's going to constantly look at a measurement and say, is this the biggest value I've seen thus far? And if so, it'll remember that, and that'll eventually become our maximum. And all the other values, what typically happens if it's not being put into a distribution, it'll take those sampled values and it'll sum them up. It'll maintain a sum value of the cumulative samples, so to say, a sum value. What it'll also maintain is what we call the count of the samples. So then at the end of the measurement interval, we're going to know the min, we're going to know the max, and we're going to know the cumulative total of all the samples as well as the sample count. Now, if you take the cumulative total of all the samples, divide by the sampled count, that's how we calculate the average value. And that's how, let's say for a queue, we can calculate the minimum value during a 10-minute period of time, the maximum value during a 10-minute period of time, and the average value during a 10-minute period of time, and how many samples we use to collect that value. And there's lots of other different ways we can look at those measurements. There's lots of other things that the monitors will do. Eventually, what we're going to do is we're going to take our metric. Now, the next type of data we have is what I think of as dimensional data. And dimensional data is going to allow us to take our metric data and give that metric data some level of context. And by giving it context is we're going to be able to ask certain questions of the metric data, and those questions are going to help to be answered by this dimensional data. So typically, dimensional data is going to allow us to answer the questions of when and where and what and which or which state did this data get taken in. So when we build our reports, we can ask those. Now, the next type of data we have is what I think of as dimensional data. And dimensional data is going to allow us to take our metric data and give that metric data some level of context. And by giving it context is we're going to be able to ask certain questions of the metric data, and those questions are going to help to be answered by this dimensional data. So typically, dimensional data is going to allow us to answer the questions of when and where and what and which or which state did this data get taken in. So when we build our reports, we can ask those questions of the report, take the measurement data, and then use the dimensional data to give them the context in order to answer the question. So for example, one type of dimensional data is time-based measurements to help us answer the question of when. When was these measurements taken? If I'm looking at a report, for what time period, when was this time period for the report? So we want to know things like the date of the measurements, the time of the measurements, the year of the measurements, the time zone of the measurements. Those are all examples of time-based measurement. The length of the interval is another example. Now, another type of dimensional data is what we think of as placement data, or asking the question, where were these measurements collected? So for example, of placement data to answer the question where is for, where is the data center? Are we talking about the East Coast data center? Are we talking about the West Coast data center? Are we talking about the production environment? Are we talking about the test environment? Those are examples of sort of placement data. Another type of data is what we call subject type data to answer the questions what? What workload are we looking at? What resource are we looking at? So for example, if we're looking at a workload, I might want to say, what application am I going to measure? Which of those, what is the name of the application? If I'm looking at a batch job stream, what batch job stream am I looking at? If I'm looking at a particular workload and I want to examine a user, what user am I looking at? What user am I measuring? That's how you measure, or that's the dimensional data for a workload. If I'm thinking about a processor, or thinking about resources at least, examples of what data, what resources, what processor am I looking at? What is the machine serial number, for example? What is the type of processor? What is the storage area that I'm interested in? What is the I/O channel? What area of the I/O subsystem am I interested in? That's examples of subject type data. And then another type of data is what we think of as, I call it adjective data, to answer the question which. So for example, if we're measuring a workload, I know I want to measure this application, so now I also want to look at which transactions of that application. I want to look at transaction A, I want to look at transaction B, so that's another way we look at dimensional data. If I'm looking at a batch workload, which of those batch jobs am I interested in? What programs am I interested in? That's all examples of adjective type data when we look at data. In terms of looking at resources, we can say we want to look at a processor, but which CPUs do we want to look at? What type of CPUs do we want to look at? What area of the processor do we want to examine in what detail? If we're looking at a I/O subsystem, which channels are we looking at? Which logical volumes? So getting down to the more details of that. And I guess the final type of data is more what I call state data. So that's kind of a combination of all of these, but concept of state data is I want to look at things such as processes that are online versus processes that are offline. Ones in which this bit is turned on as opposed to a resource where this particular bit, whatever it may be, is turned off. That's sort of a state type of thing that we might want to include. I might want to look at certain logical volumes that are maybe online but versus the ones that are offline, or the ones that have this sort of state versus another state. That's an example of adjective-based data. So the next data, as I said, is dimensional data. Okay, so now for the bonus. I mentioned at the beginning of this video that if you stuck around, I'd give you some key recommendations or things to do in order to start analyzing data. And here's what they are. Now, first thing to remember is when you're analyzing data, we need to get reports. Whether you're getting the report from a reporting product or you're creating your own reports. So that's a given, and in later videos I will be explaining how to create these reports and what reports to create and why and things like that. Now, one of the key recommendations I do want to say is don't bog yourself down with lots of unnecessary reports. Whether you're looking at reports from a reporting package or a monitor, or you're asked to create reports, or you're asked to give a presentation of reports, one of the most common mistakes that are made is that people overdo it. Many times, in order to get across the point of your analysis, to further your analysis along, you only need a few reports. You don't need hundreds and hundreds and hundreds of reports to answer one specific question. Maybe a few reports, but not lots of reports. You want to have a lot of reports to choose from, but you don't necessarily want to bog yourself down with lots of reports during your analysis or when you're presenting your analysis. So assuming that you're going to be creating reports or getting reports and not bogging yourself down with unnecessary reports, here are some additional recommendations. First, when you're doing an analysis, you want to make sure you formulate your question. And that's probably the most important thing, whether you're looking at a report that's created for you or you're creating your own. What is the question or set of questions being answered by that report? So for example, if you're looking at a workload, what questions do you want to ask of that workload? Are you trying to understand the performance, the capacity? Are you understanding response time, who's suffering, how to trend something? There's lots of things to look at for a workload, so formulate your questions. And the same thing is true for resources. When looking at your resources, you want to understand, what resources I'm looking at and why you're looking at those resources. Do you want to understand how they're currently being used, how the growth on the resources or usage of the resources is growing, the capacity of the resources? Again, all to formulate the question is what's needed. Now, once you formulate your question, you need to understand the two categories of data that we discussed in this video. So naturally, you're going to have your metrics, and you're going to have lots of metrics to choose from when doing a computer performance analysis. So which metrics do you choose? So remember, you have your cumulative data, you have your interval data, your snapshot data, your sample data, and there's many other different types of measurements and subcategories of measurements that you're going to see. And then, of course, what you want to do is take those measurements and perhaps plug them into a set of formulas, and then, of course, the formulas will help further your analysis along. So the formulas I usually mention are things like counts and averages and percentiles and utilizations and ratios and all sorts of things like that. Now, after you know your metric and the measurement and the formula that you want to use, naturally then you want to understand sort of dimensional data that's going to help you answer your question. What time period do you want analyzed? Or what is the analysis for? For where is this analysis being done? In other words, what data center, what platform, whatever. in terms of what is being measured. What is being measured? Are you measuring processors? If you're measuring processes, what processes are you measuring? If you're measuring some other resource, what other resource are you measuring? And then, of course, you want to know sort of the details of that. Again, back to processor. You want to know, am I measuring processor? What processors am I measuring? What type of processors are you measuring? Which processors are you measuring? Which areas of the processor are you measuring? And the same thing is going to apply to all your different resources. And the same thing is going to be true if you're going to be monitoring or analyzing an application, which transactions or which workloads or which parts of the workload do you want to have analyzed. Then, of course, what you have to do is understand different states. In other words, which ones you want to eliminate, what I call the on-off state, the online, offline, the yes-no, whatever the state may be for that resource. And then the next thing you want to do is once you have a well-formulated question where you understand the metric data, you understand the dimensional data that you want to plug into a report or the report that you have already created, the next thing you want to do is look at that report, analyze that report. If it's not created already, you have to create the report. If it's created already, then we have to analyze the report and hopefully draw some conclusions. The concept of creating a report will be covered in future videos, and the concept of analyzing reports will be covered in many videos as well, because the way you analyze a report is going to be very relative to the measurement you're measuring and the area that's being measured, and I hope you join me for those videos as well. So again, this is Peter Enrico. I hope this video helped you understand data a little bit better. If you like the video, click the like button. And if you have any comments, please list the comments below. And I want to thank you. And I'll see you again in a future video.